Hello guys, in this video I'm going to talk about the access control list concept, and this is under module 4 of Cisco curriculum. So we're going to discuss why do we need to configure an access control list in a router, and because this is part of the network security that is used to protect our network from any unauthorized person. And we're going to discuss also the different types of ACL and how are we going to apply it in Cisco interface. So let's dive into the PowerPoint presentation. So ACL concept. ACL, once again, this is also known as the access control list. And we're going to cover the following subtopics. The module title is the ACL concept. And the module objective is to explain how ACLs are used as part of network security policy. So first up is the purpose of ACL. We're going to explain how ACLs filter traffic. We're going to discuss also the wildcard mask in ACLs. We're going to explain how ACLs use wildcard mask. And of course, how are we going to compute the wildcard mask, just like what we did in OSPF. And guidelines for ACL creation. We're going to explain the guidelines in creating an access control list. And of course, we're going to discuss the different types of IP version 4 ACLs. We're going to compare the standard and extended IP version 4 access control list. Alright, so what is the main purpose? What is the purpose of access control list or ACLs? ACL is actually a series of iOS commands, or the Internet Operating System commands, that are used to filter packets based on information found in the packet header. So by default, the router does not have any ACLs configured. When an ACL is applied to an interface, the router performs the additional task of evaluating all the network packets as they pass through the interface to determine if the packet can be forwarded. An ACL uses sequential list of permit or deny statements known as access control entries, or ACEs. Take note that ACEs are commonly known or commonly called ACL statements. So these are the series of statements which is called ACEs, or access control entries. When a network traffic passes through an interface configured with an ACL, the router compares the information within the packet against its ACE in sequential order to determine if the packet matches one of the ACEs. And this process is called packet filtering. So the packet filtering is just a series of sequential order that has to be filtered before the forwarding of the packet will continue. So that is the main purpose of access control list. This is a packet filtering procedure. Now, the several tasks performed by the routers require the use of ACL to identify traffic. So what are these tasks? The task of the router after configuring an ACL, or the function of ACL, is number one, to give the router the task of limiting a network traffic to increase network performance. So that is one of the most important tasks of a particular ACL. This is used to limit network traffic because limit means the network administrator can be able to deny or permit a particular traffic. For example, if an organization have a video conferencing or meeting, video conferencing meeting or video call, the network administrator must prioritize this traffic in order to improve the network performance, to avoid any traffic that will go along with a video conferencing, if that is the main priority to be forwarded by the router. Another is it provides traffic flow control. So using ACL, you can also control traffic by entering your network, entering and leaving your network. It also provides a basic level of security for network access. Because of the permit and deny characteristic of or task of a access list, it provides a level of security because you can actually deny a particular user to access a particular device. For example, sales department user cannot just, if you want that user not to access web server or the file server, you can do it by configuring an access list because of the filtering capacity of the access control list. You can also filter traffic based on traffic type. It can be a HTTP traffic, telnet traffic, okay, and other protocol types. Screen host to permit or deny access to the network services. That what I discussed a while ago. You can screen, you can limit a particular host in accessing different network services. Like if you don't want the users to access the network printer, the file server, you can make an access list statement in order to prevent other users from accessing network services. And you can also prioritize a certain classes of network traffic, just like what I mentioned. If you want to prioritize a video conferencing traffic that to be priority because of the bandwidth resources of a video is much higher than the other traffic that is flowing in the network, you can put some filtering just to prioritize a particular network traffic. So these are several types of tasks that an access list can provide. Packet filtering controls access to a network, okay, by analyzing the incoming and our outgoing packets and forwarding them or discarding them based on the given criteria. There's always been a criteria in creating an access list in order for the packet to be filtered in the router. And packet filtering is actually occur in layer 3 or layer 4 of the OSI layer. We all know that layer 3, this is where the IP addresses resides, and layer 4, this is the TCP and UDP protocol is being considered. So packet filtering is actually works at layer 3 and layer 4 of our OSI model. Now, Cisco routers supports two types of access control list, and these are standard ACL, and this standard ACL only filter at layer 3 using the source IP version 4 address only. Again, standard ACL is only filter at layer 3 using the source IP version 4 address only. Whereas in extended ACL, ACLs filter at layer 3 also, but using the source, the destination IP version 4 address, and also filters layer 4 using TCP, UDP ports, and other optional protocol type information for granularity or finer control. Like if you want to permit or deny telnet, which is 53 port number. If you want to deny or permit FTP or TFTP protocol, which has a port number of 21 or 22, or SMTP, okay, and other protocols. These are the protocols that you can permit or deny using an extended control list. This is more extensive or expanded type of ACL rather than the standard ACL, wherein in standard ACL you can only filter at layer 3 using the source IP address only. Now, what is the operation of an ACL? Since ACL defines the set of rules that give added control for a packet that enter inbound interface or interfaces, packets that relay through the router, and packets that exit outbound interface of the router. So ACL can be configured to apply inbound traffic and outbound traffic. As you can see in this figure, all traffic that is coming into the interface of the router is considered an inbound access list. And traffic that is coming out from the interface of the router is called outbound access control list. Take note that ACL do not act on packets that originate from the router itself. So it does not act a packet that originate from the router itself. Only the packet that is an inbound and an outbound packet. An inbound ACL filters packet before. So on inbound ACL, it filters the packet before they are routed to the outbound interface, like this one. Before it go out from the outbound ACL, the inbound ACL filters at this before entering outbound ACL, the filtering is happening on this interface. That is why this is more efficient. An inbound ACL is efficient because it saves the overhead of routing a lookup if the packet is discarded. Because at this point, if the packet doesn't match the given rules or does not match the ACL entries, automatically the packet will be dropped and it will not take, it will save overhead on the CPU processing of the router before it goes through the outbound ACL. However, an outbound ACL filters packets after being routed. So it filters after being routed regardless of the inbound interface. Now, to continue with the ACL operation, when an ACL is applied to an interface, it follows a specific operating procedure. Here are the operational steps used when traffic has entered a router interface with an inbound standard IP version 4 ACL configured. So using the standard ACL and using the inbound interface, these are the how the packet is being filtered. Number one, the router extract the source IP version 4 source. Since this is standard ACL, the router extract the source IP version 4 address from the packet header. So in the packet header, there is an information there of the source IP version 4. This is to be extracted first by the router. And then the router starts at the top of the ACL and compares the source IP version address to each ACES in a sequential order. So when a match is made, the router carries out the instruction, either permitting or denying the packet and the remaining ACES in the ACL, if any are not analyzed. So when a match is made, the router will carry out the instruction, either if the instruction is permit or deny the packet, and then the remaining will be discarded. And the last procedure will be if the source IP version 4 address does not match any ACL in the ACES in the ACL, the packet is discarded because there is an implicit deny. So this is the most important things to remember here. There is always an implicit deny in every ACLs. This is automatically applied to all ACLs, the implicit deny ACE. The last ACE statement of an ACL is always an implicit deny that blocks all traffic. It is hidden and not displayed in the configuration. So it is hidden. You cannot see it, but it is an implicit deny. That is why an ACL must have at least one permit statement. Otherwise, all the traffic will be denied due to the implicit deny ACE statement. All right? So before the last statement should be, there must be at least one permit statement, because there is a hidden implicit deny command in the ACL. This is applicable to all the routers to be configured an ACL. Now, what is the purpose of the wildcard mask in ACL? Just like in OSPF, there is a wildcard mask also in ACL. The wildcard mask is actually similar to subnet mask in that it uses the ANDing process. ANDing process, that means 1 1 1 1 0 0. That is the ANDing process. 1 and 1 is equal to 1, and 1 and 0 equals to 0. That is the ANDing process. This is also applied to identify which bit in IP version 4 address to match. So unlike a subnet mask, in which binary 1 is equal to a match and binary 0 is equal to not match, in wildcard mask, this is a reverse. In wildcard mask, 1 is match, 1 is ignore, 0 is match. That is the difference. In wildcard mask, bit 0 is meaning there is a match the corresponding bit value in the address. While in wildcard mask, bit 1, this is ignore. This is the reverse operation for subnet mask. For wildcard mask, 0 match, 1 ignore. But in subnet mask, 1 is equal to match and 0 is not a match. So a little bit confusing, but you have to remember that speaking of ACL, 0 must always be match. Match means you have to match the corresponding bit value of the given IP address. And 1, that means you have to ignore the corresponding bit value in the address. The wildcard mask is just an inverse of the corresponding subnet mask. So just an inverse of the corresponding subnet mask. So these are the wildcard mask overview. If you have a wildcard mask of 0.0.0, in the last octet in binary, that means match all octet. So considering the last octet 0, that means that is 8 zeros. The meaning is you have to match all octets. Remember, 0 is equal to match and 1 is equivalent to ignore in wildcard mask. For example, this 0.0.0.63, the first 3 octet must match because of 0. So that means these 3 octets, the 3 IP address of this should match. And then 63, if converted into binary numbers, this is the equivalence. So that means the 00 here must match and 11 here is ignored. The same is true with this. The first 3 octet must match and the 15 here is this is the equivalent binary of 15. That means these 4 zeros must match and this ignore. All right. So those are the examples of wildcard masking, how the bits is being matched or ignored. Always remember 0 is a match and 1 is ignored in wildcard masked in access list. So this is just an example. First, you have to convert the subnet mask into binary and just invert it. invert the 0, convert to binary, and all 1 should be converted to 0, like this one. All are, just invert it to 0, invert it to 0, this one invert it to 0, and 0, 0, invert it to 1, and then convert it into decimal form. So this is 0.0.0.0.255. That means this is the wildcard mass. So you have to match the first 3 octet, and the 4th octet must be ignored. The same is true with this. So just invert 1 to 0 and 0 to 1 to get a wildcard mass. Okay, another shortcut method for calculating wildcard mass is just subtract the mass from 255.255.255.255. This is another method. You just need to subtract the given subnet mass from this quad 255. So give an example here. Assume that all the users are permit access 10 to permit access to all the users in this network. So the subnet mask is 255.255.0. Using this method, just subtract this one from 255.255, you will arrive at a wildcard mask of this one. 255 minus this one is equal to 0.0.0.255, which is equivalent to the subnet mask of this subnet. So the command for access list in this particular example is access list -10. This is the number. We're going to discuss this later on. Access list 10, and then this is the rule. Permit the source IP, and then this is the wildcard mask. So that means to say the first 3 octet must match, and the 4th octet must be ignored. All right. So the same is true with the next example. Just get the subnet mask and subtract it from 255.255.255. You will get a wildcard mask of 0.0.15. And this is also a permit. This is the command. Access list 10, permit 192.168, source, and then the wildcard mask. So that means to say 00 must match, the first 3 octet must match, and the last bit must be ignored. Right? Oh, it was mentioned already, this one. Wildcard mask. Okay, wildcard mask to match a host. This is an example of wildcard mask to match a host. If you want to match a particular host, for example, this one given 1.1, since 0 equals to match and 1 equals to ignore, to match the specific host IP version address, a wildcard mask consisting of all zeros is required. So for a particular address, you can actually use the quad 0 just to allow or to deny a particular host. Okay, so quad 0 means permit or deny a particular IP address. like this one. So the access list, if you want to permit this particular or specific IP, you just use the quad 0 so that all of the octets will match. If this will match, it will permit the IP address, the source address will be permitted. Okay, as you can see in this illustration, IP version 4 specific, the wildcard mask. Okay, and then permitted IP version 4. Okay. So the same with wildcard mask to match an IP versions, this time a subnet. So for this particular example, it permits a particular subnet, this one. So this is the subnet. To get the wildcard mask of this, first you have to get the subtract the subnet mask from 255.255.255. So you have to subtract what is the subnet. Is last 24 is 255.255.255.0. So the result will be your wildcard mask, which is equivalent to that 0.255 minus 0 is 255. That is why the wildcard mask is this one. Okay, to permit a subnet, particular subnet. So therefore, if you want to permit this subnet, this is the command. Access list 10, permit. This is the subnet. And this is the wildcard mask. Remember, we are still using a standard access list wherein source IP version 4 is being used as an argument and the wildcard mask. So again, an example of wildcard mask to match an IP version for address range. So in this particular example, we are considering an address range. That means we need to permit the host .16, .17 up to .31/24. You need to permit this .16 up to .31 up to .31. So how are we going to get the how did they arrive at this wildcard mask? So they use the summarization formula wherein we can summarize the 192.168.16. So that starting from that 16, so if we're going to convert that one to 1,248 1, 2, 3, 4, 5, 6, 7. 1, 2, 4, 8. This one, another one. 1, 2, 4, 8, 16. So this is 16. And then that 0. Sorry. That 0 up to 0. Right? So in summarization, this is 17 that 0 to 0, and then 16, 18, And then 19, 16 plus, this is 18, so 19, 8, 16, so 18 plus 1, 19. This is fourth octet up to 0, 0, 0, 1 up to 31. So 1, 1, 1, 1. So to summarize this one, the summary of this is just draw a vertical line to the number that is not changing. The number that is not changing is 16. So draw a line from here, and then these four bits now will be equivalent to 1. So this will become 1, 1, 1, 1. And on the right side of the vertical line will become 0, 0, 0. So therefore, the subnet mask for this is, since this is slash 20, it becomes slash 1, 2, 3, 4, 5, 6, 7, 8, and then another 1, 2, 3, 4, 5, 6, 7, 8, plus this one, 1, 2, 3, 4, and then 1, 2, 3, 4, dot 4 octet. So therefore, this is equivalent to 255. This is the subnet mask now of that IP, 255. Dot, converting this into decimal, this is 240. Dot 0. Okay, so therefore, if you're going, this is the subnet, if you're going to subtract that one, 255, that 255, that 255, that 255, minus 255, that 255, that 240 minus 0, because this is 0, the wildcard mask is 0, that 0, that 5 minus 4 is 2 minus 2, 0, 5 minus 4 is 1, 5 minus 0 is 5, and then 255 minus 0 is 2, 555. So that's why they get this one. They use the summarization concept. Okay, so starting from 16, and then draw the line, which is the number that is not changing on the left, convert it to 1, and the bits that is changing, convert it to 0, and then count the number of ones from this octet. That will be the new subnet mask. So this is actually equivalent to 16 plus 4 is 20, slash 20. Right? So that is why they arrive at 0.0.15.255 address range. In order to allow the range of IP addresses, we should apply the summarization. All right, so let's continue on the part 2 of this video. Let's stop on this portion. I'm going to continue this video in part 2, just to limit the time of this video. I'm going to make it part 1 and part 2. This is the part 1, and we will continue the discussion of ACL in part 2.